Good morning, everyone. My name is Melissa Solaris. It's a pleasure to be here today with another webinar. Today we have the topic Active Security with Huawei Optimizers and Rapid Shutdown. For today's agenda, we have first the welcome words in charge of our country manager for Jamaica, Johnny Kennedy. After that, we have the presentation of the topic in charge of our pre and post sales engineer, Julio Lopez. Then we'll have a space for the Q&A session. So please, you're welcome to write all your doubts in the chat box. And we're closing with the closing words. So let's start. Please welcome Jenny.
Thanks, Melissa. All right, everybody. So first, thank you so much for coming. As you guys know, Owen makes it a point of our duty to educate all of our partners, all of our customers, especially anybody that needs additional information about the solar space. As a result, we have put this webinar together to give you all an opportunity to ask questions from our very, very, very educated and talented team. Now, as Melissa mentioned, if you guys have any questions or recommendations, you drop them in the chat. And at the time of our Q&A, we can always reference your questions, or we'll have an active conversation where we're engaging and trying to ensure that you guys are on the same page in terms of the information that's being provided by our tech team and our point person today, Julio Lopez. So without further ado, thank you so much for coming, and we're going to jump right in. Taking it over to you, Julio.
Good morning, everyone. Give me 1 second. Please let me know if you are able to see my screen.
Yes, we can see it.
Great. So a brief conversation before we start the presentation. Smart standard guidelines will more than likely be like the safety and what comes to the operation and maintenance and the safety features that our solution offers, not only for residential but also for the CNI segment. In general, we work with what is high voltages, so we have to keep in mind that the possibility for an arc is present. So to begin with, what is an arc? An arc is a glowing phenomenon caused by the ionize of the air when the electric conduction is close to another conductor. A lot of words, very heavy, very hard to understand, but in general terms is where you have the arc strength is closely related from a voltage difference between conductors and the distance between them. So majority of the arc faults that we find are also known to be not only but due to welding inside of the PCB of every single inverter or device that manages high voltages. The connection points that we have on the DC side connections or also on the AC side connections and damage the DC cables, or in any case AC cables as well, because of the regular usage or aging of the plant. We can see that the cause of this may come to fire because we're doing 3000 Celsius on every single spark that the arc creates, causing fires, causing a lot of damage in the household. Due to those things, we are actually recommended and we actually pursue excellence as Huawei brand. So the majority of these cases, there are multiple solutions where you can actually acquire an AFCI, which would be the abbreviation for arc fault detection. And for those things, we can find devices in the market that can be installed between the PV side and the inverter that does not acquire this. But in that sense, it would cause the whole system to be more poorly compatible and have a higher cost. Majority of our inverters have AFCI in their system, so the connection is simpler. You connect from the PV side straight through the inverter, making it safer, lower cost, and we actually are compliant with majority of the standards in the market currently. I am not sure if you guys can hear the video, but it's not really important. It's talking about a news where, well, you would have a commercial industrial plant burning over due to the fact of an arc fault. This would be happening due to the fact of a bad connection between panels. And in general, they couldn't have done anything to prevent this fire or to actually um, seize the fire because the firefighters are not capable of doing their job due to the fact of electricity fire, because this is an electric fire. In that sense, what we're looking at this point is not only the safety for the client, but the safety for the firefighters, the people that go ahead and do the labor of protecting our homes and our businesses. This is what we call the rapid shutdown ensure fire safety. Majority of the inverters now in the market does not have this. You would have to require this from an outside source and get it from another vendor. And that is where our optimizers come in. The AC must always be enabled on the system. This is something that we require. It's something that we emphasize a lot on. The module level rapid shutdown ensures safety not only for the situations of over installation, over roofing installation, but on a general talk of when it comes to a general build and safety of a plant. During installation and operation and maintenance, the optimizer disconnects the PV strings voltages to ensure the safety of the personnel installing or going through the operation and maintenance. In the case of an emergency, such as fire, floods, etc., us in the Caribbean where we get a lot of hurricanes, it is very important to have this type of security. So if there is a case of an emergency, there is no voltage going through it in any case of flooding or fire to ensure that the safety or the rescue team are okay to operate and do their jobs. Now, moving forward, we do not only offer a system where dust protection, we have generally speaking, we do have AI running through the inverters with the optimizers, and they study every single curve that occurs on the DC and AC side to prevent any arc faults. So generally speaking, our inverters are capable of reading every single production of energy that is being made on the photovoltaic modules and understand that the curves are happening, and what they're doing is that they study every single one and detect if there's any arc fault. So with further ado, let's get started on the overview of our optimizers. Some functions and features on overseas is higher yields, active safety, flexible designs, and smart operation and maintenance. The higher yields track the maximum power point of each PV module independently. Active safety, like we mentioned before, our optimizer modules offer module level rapid shutdown, disconnecting voltages to a rapid and efficient way. AI intelligence to detect arc fault in zero point 0.5 seconds. Flexible designs, this would mean that we are able to have a bigger PV side than the AC side and have a better ratio. And smart operation and maintenance, I'm pretty sure this is very clear, but the module assist shuts down and you're able to actually do any type of maintenance work, washing of the panels, verifying the cables, etc., without having the fear of any arc hurting our crew, and especially to actually be safe on the installation as well as the operation and maintenance. A quick generation of physical layouts on the app, so you are able to see if there's anything wrong with your panels at any point. You can verify that that panel is you can actually go and verify if the panel is broken, fix it in less than 1 hour. Configuration principles. These are our optimizer that the sun 600 watt and 450 watt are compatible with the L1, LC0, M2, and M3. Those are the strings that you're able to have a minimum of 4 optimizers, 4 and 6, in the respectfully with the modules of the inverters, up to 35 and 25, having a string power output limit of 6, 10, 12, and 12 kilowatts. Then we have, this is for the residential side. For the commercial and industrial, we use the Merck 1300 and the Merck 1100. And those are the respective voltages, number of optimizers support, minimum to the maximum, and the capability of the ratio to each string. Some of the things that we quite got often when we're designing a plant or helping you guys design a plant with optimizers is if the solution can actually have a fully optimized configuration. This is possible. We can also have partial installations with individual strings, and we can have, for example, cascade inverters that one would have a fully optimized solution and the other wouldn't. That is fine. That would work as well. What we cannot have is a mixture of having one string fully optimized and then having a partial string optimized connected together. That wouldn't work. As well as the optimized, we can have a fully optimized and then a partial optimization on a string. For example, in the case of give me a second, on this side, where you would have a fully optimized inverter and then a partial optimized inverter, having an MPPT empty without any optimizers, and then you can have an optimized string. Some things to note is that you are not able to have a 1100 watt inverter solution fully optimized in one string and have the 450, for example, optimizing the other string of the inverter. That is not possible. Some other things to have in mind is that you can have only one string can be connected to each MPPT. This is something that we have answered quite a few times. You would have one MPPT per string. You cannot have two MPPT, have different strings going to the same MPPT. That's not possible. The derating part would be if you would have one longer string than the other. Try to always make it somewhat of the same to keep in mind the balance of the plant and keep the inverter from derating. Some of the maintenance and troubleshooting. This scenario here is something that I found very interesting. This is for the fire situation where you would have a DI button, which is the switch off of turning on and off the optimization part on the panels. So in case of a fire or something, they should be able to press that button and the NEC 2020 would suffice with that, which states that the voltages on the panels would have to drop below 30 volts under 30 seconds. So some of what the rapid shutdown does is when the system is not powered on, the optimizer side has not powered output to ensure personal safety. After the system is powered on, the optimizer automatically starts to produce, and it would work in one of two ways, which is the bypass mode or the bulk mode. The rapid shutdown will be triggered with the following methods, which would be one, if the AC side is switched off, and two, if the DI button is pushed. And also there's a third way where you can actually set the DC switch at the bottom of the inverter and you turn it off. Then that would turn off the optimizers as well. Some of the things that you are able to do is have a physical layer, a physical layout on the app, as well as locally as remotely. So the physical layer will allow you to understand a bit of what is happening on the plant on the plant and with the panels without actually being there. So you're able to see the different radiation that the panel are having daily, and you can see the status of the panel here and see if it's okay, if it's producing what it's supposed to produce. And if there is something, an error happening every day in very large plants, we're talking about hundreds and hundreds of panels. This is a very useful layout where you can verify and see what is happening with the panels. So you can say if operation and maintenance, you can reduce operation and maintenance by just having an alarm in the inverter and saying, hey, this string is something wrong is happening to the string. With the optimizers, you can actually go and see which panel is the one that is having any issues and send a team of 2 people instead of 5 to 10 and having it resolved between an hour instead of 3 days of looking for a mistake, error, or arc fault. This is something I believe is very useful for commercial and industrial size plants, as well as very large residential plants. On this side is something that we call the power optimization design and higher DC ratio. In this sense is where the optimizer helps the string to be a bit bigger. So we can have, instead of having a string of 14 pieces, which would mean panels, we can actually have a ratio of 1.95 between DC and AC, where you can just overtake the panels at the bottom of the design and move forward with that, having a larger string, making it a lot more helpful. At this point, I don't know if you are open to any questions. That is all for me. I'll turn it back to you, Melissa. Thanks a lot.
Thanks, Julio. So yeah, it's the part of the question. So please, if you have any doubts, we have time to resolve it. So I invite you to write in the chat box or in the Q&A option. So we're going to give it time. Also, just like the the webinar before webinar, we're going to share all the recording, the material, the presentation, so you can consult it. So don't worry about that. To more if we resolve the doubts. Also, if you have doubts about you have it in, I don't know, another time in the day, you can also write us. Please, Julio, if you can share your email address so people can contact you if they have doubts, and also Rodrigo, if you can help us with that, so we can clarify in other ways. Thanks, Julio. Thanks, Rodrigo. And so I'm going to invite Jenny so we can give the closing words for today's webinar. We don't have any doubts here, so
All right, thanks, Melissa. All right, team, thank you so much for coming today. As Melissa mentioned, if you guys have any questions or any concerns, the recommendation here would be to reach out to Julio. He has dropped his email address in the chat. I'm also seeing where Rodrigo has dropped his email address in the chat as well. So that will give you guys very quick and easy access to any questions or any concerns that you may have. Thank you so much for coming to our webinar today and have a wonderful rest of your day.
thank you, Jenny, and thanks again, everyone. We're going to see you in another chance, in another webinar with another topic. So let's see you another day. Have a great day, everyone, and just remember the recording is going to be available soon, and the presentation is also going to be available in a survey, so you can fill that survey. Is going to help us with all to improve these activities. Thanks. Bye bye.
Thanks, team.